So now I'd like to invite Prof Stefano Schiavon and Prof Daniel Rodriguez from the University of Berkeley to give their presentation on SinBerWELL, the Singapore-Berkeley Center for City Sustainability and Liveability. Prof Schiavon and Prof Rodriguez, please.
Hi, good morning to everybody. I'm Stefano Schiavon, I'm a professor here at UC Berkeley, and today, together with my colleague Daniel Rodriguez, we are going to introduce our proposal for the Singapore-Berkeley Center for City Sustainability and Liveability. As human species, we evolved for thousands of years in small community and mainly outdoor. And roughly 10,000 years ago, when we started to develop agriculture, we started to coalesce in bigger settlement. Right now, most of the world population live in cities, and living in city is better than living outside city. People that live in city tend to be healthier, tend to be wealthier, tend to live longer. And city has solved many of the difficult problems that they face in the past. We have now city that can provide safe water, that can manage the sewer. We have city that can stand flooding and earthquakes. But there are new problems that we are going to face in the future. And as Dr. He mentioned just a few minutes ago, these ones are VUCA problems that are difficult to define. There are problems that tend to be uncertain, and problems that often we do not control, like, for example, in the case of climate change. Regardless of what Singapore is doing, the effect of climate change will be felt in Singapore with rising temperature and rising sea levels. The same is, for example, with particles and pollution present in the air. Some of that is produced and managed within the boundary of a city or of a country. Other times come from another nations. And now that the World Health Organization reduced the existing target for outdoor pollution, it's much harder to achieve this limitation. Other problem, here we have a list of risk factors that are present in Singapore, are related to people behaviors. What they eat, how long they sleep, how many hours of physical activity people do, which type of air quality is around people. Another problem that cities are facing, and we have felt it particularly hardly during the pandemic, is that the more urban is a country, the higher is the prevalence of anxiety disorder, depression, and sometimes substance abuse. We are a group of scientists that want to focus on environmental stressor, issues like air quality, noise, temperature, and how these affect people, both directly but also indirectly, how these parameters affect how much physical activity we are going to do, how stressed we are, how anxious we are, how well we sleep. And usually in the past, these problems were solved at specific conditions. For example, there was an agency or a government department focusing on housing, another one focusing on schools, another one focusing on commercial building, another one focusing on parks. But as Dr. He mentioned before, we need to have a center around the person. People are the center of our focus. People, sleep in a house that may be exposed to noise at night, and therefore they don't sleep very well. And then they go to work or to school, and when going to school, they are exposed to pollutants, and then they work or learn, and then they go out. They may go to a mall, they may go to a hawker center, and then they go home. Our program will focus on assessing those exposure and look for mitigation. SinBerWELL has a clear statement. We want to improve the sustainability and livability of Singapore by managing the digital transformation and its implementation in the built environment. We developed some metrics, the one that Professor Spanos mentioned before, to assess our own work. We want to improve the quality adjusted life here. We want to improve the subjective well-being of people, and we want to reduce the greenhouse gas emission. And we develop quantifiable metrics and goals. How are we going to do that? We organize ourselves in theme. We are a group of roughly 30 people, and we're all focused around the theme that focusing on understanding people exposure. This is what we call the team A, the people team. And then we look how these people move in different environments. We want to focus on the outdoor environment. We want to focus on indoor environment within buildings. And we want to see the relationship between these two that happen at the city level. All of this is based on a clear understanding. We agree with what Peter Holt mentioned before. We want to be evidence-based, and therefore we want to collect data and we want to extract information from this data. And we want to test our condition. We want to be part of that living lab that was mentioned before. And that's why we proposed the HIL laboratory. And now I pass the word to my colleague Daniel to start to introduce these 5 teams.
Thank you, Stefano. Good morning, afternoon, evening, everyone. So the first theme is the people theme, as Stefano suggested. We bring experts in public health, in medicine, in exposure assessment, in urban planning, epidemiology, with a focus on environmental health. The motivation, next slide, please, Stefano. Undergirding this theme is that, as Stefano said, the science of sustainable cities can benefit from a person-centered focus. And this Dr. Lee Min-hee also suggests in the presentation earlier. We have limited knowledge and data about personal exposures of urban residents and their additive impacts on health, on well-being, and on sustainability. Therefore, policy responses and interventions need awareness of cumulative impacts that arise from those daily personal patterns. This is important for addressing important causes of health functional impairments and disease burden in Singapore. Luckily, life expectancy in Singapore is exemplary. It's highest. And thus we want to focus on the functional health aspects. For example, improving air quality because of all the impacts that it might have on daily life, quality of life. Associated also with meeting the needs of an aging population. And we want to develop and test solutions at several levels. The theme's mission are twofold. First, to characterize environmental exposures and their cumulative impact on health and well-being, and then develop individual and community-centered interventions. What you see in this slide is our framework for intervention and thinking about this theme. It's based on the fact that cardiometabolic health, including heart disease, but also diabetes, for example, outcomes like weight gain prevention, or the health of the muscle system and the skeletal system, or mental and brain health, are all large contributors to Singapore's challenges around functional health and livability. On the left of this chart, you have a number of aspects that we think of them as the modifiable aspects of urban living, which determine urban sustainability. These are the key aspects or exposures that our theme members can measure. From the top, you have heat and thermal comfort, both indoors and outdoors, with the concerns around heat island that were raised earlier. We have particulate matter, again, indoors and outdoors. This remains one of the top 10 risk factors for non-communicable diseases in Singapore. Mobility, haze from burns in neighboring countries, and industry are the main sources of outdoor air pollution, and these move indoors as well. Noise and light, as they affect physical activity, sleep, and stress. And then green and blue spaces, because they offer opportunities for recreation, relaxation, physical activity, in addition to the biophysical and ecological benefits that they provide. Taken together, these elements in the left affect the elements in the middle. This we can observe quite easily. Physical activity, sleep, stress, maybe depression. Over time, this will affect the right-hand side box. These are more difficult to observe immediately. They take a long time, and that's why the arrow is dashed, because we might not observe it immediately in a study like SinBerWELL, but we have simulations and we have empirical evidence that will allow us to connect those middle behaviors with the right-hand side boxes. Next slide, please. So how will we do this in this theme? Our main vehicle for this theme, and that it also really supports other themes that you'll hear about in a minute, is the COBRA study. And COBRA is one of the many NUS School of Public Health cohorts for population health studies. we leveraged this deep experience that NUS has within their School of Public Health to create a research collaboration around this cohort, which is aiming at about 1,500 participants aged 21 to 69, observed over 9 consecutive days over a number of waves. Some of the measurements that COBRA is taking already, we're interested in. Things like GPS to track people over space and time, or the monitoring of blood sugar, or the monitoring of physical activity. Our vision here is to build on this great momentum and add a few more things. First, expand the measurements to cover some items that I described in the framework before that COBRA is not covering right now. And second, also add another big cohort of participants, another 1,000 participants that would allow us to be opportunistic about targeting certain questions of interest. They don't have to be individual, they could be precinct or neighborhood questions to maybe bring in the evidence to support the types of decisions that need to be taken for a healthy and a sustainable Singapore. Next slide, please. So what are some solutions that could emerge from this? And I'm going to highlight on an example at the individual level. We will be able to be based on the observed behaviors, as well as some micro predictions that come from the next theme that I will introduce, in order to help individuals make health enhancing choices. In this example, if someone is traveling from A to B, we might be able to, through an app, encourage them to take a different route to avoid a certain plume of pollution that might be concentrated in a certain area, or maybe delay a trip, or maybe move from the bus to the train for a reason that we are observing and modeling in our system. Next slide, please. Let me now describe the second theme, which we call theme B, which focuses on the environment, specifically the mitigation and adaptation for healthy outdoors. And here we bring out also a very diverse and interdisciplinary group of researchers focused on environmental, acoustical, and civil engineering, public health, a physicist, yes, and atmospheric science with a focus on air quality and noise exposure. The critical motivation for this theme is the lack of spatial, temporal, granular, and personal data about air quality, noise, and heat exposure, and how they're connected to how individuals move in space. Next slide, please. Our mission in this theme is to seek to measure exposure to these ambient stressors while simultaneously mitigating their magnitude. So you see the connection with the theme A as well. This is about the exposures. This busy slide that's coming up, thank you, depicts two major themes. One are the main contributions that this theme will bring to the table. First is on modeling techniques to integrate multiple methods and data streams. So it's a methodological contribution. The second one is very focused to Singapore, which is characterizing the drivers of air quality and greenhouse gas emissions at a very fine level in time and space. And the third one is to connect the outdoor and the indoor perspectives at the personal level. The data and processes that will help us with this approach include the satellite measurements at a very fine scale, that's the upper left-hand side of this figure, in addition to a comprehensive neighborhood mapping of concentrations of CO2 and pollutants. We've done this in Oakland, the San Francisco Bay Area. You see a picture in the middle here of this Google vehicle that was traversing space, all the streets, to create this time-space information about the concentration at a very high resolution. We're now doing this in a variety of different cities worldwide, including Paris. The map on the upper right-hand side shows exactly the depiction spatially of these 50 meter resolution maps of air pollution concentration. Third, we're using on-the-ground sensors. In this case, we're showing the Beacon network in Berkeley that shows greenhouse gas fluxes over time. This allows us to develop time-sensitive inventories to be attributed to the different sectors of the economy, industry, mobility, housing. What you see in the bottom right is precisely those fluxes of greenhouse gas emissions over time at a very high time resolution before the pandemic, shown here in purple, and after or during the pandemic, shown in green. And you see the difference in amplitude and the difference in spread of those fluxes that are very important. The next slide shows the fifth element of this important addition, which is a personal monitoring. This personal monitoring will allow us to tie the information about the ambient concentrations with what individuals are actually exposed to. Concentrations are important, but not enough. We combine this information with physical activity, for example, accelerometers. We can identify when people are having high inhalation rates and therefore high inhaled doses versus places where maybe they are more sedentary and therefore those inhalation rates are lower. What this means for policies are quite interesting, because if I am in a gym exposed to poor air, I will need to improve the ventilation of that indoor space quite significantly. Or if I'm walking along a street that is highly polluted, I will need to think about either behavioral interventions or physical interventions to mitigate exposure to those high pollution levels. Next slide, please. The other element that the group is focusing on are these this information about the acoustic environment, sound both indoors and outdoors, identifying areas of high exposure, especially in high-risk contexts where people are spending significant amounts of time, or perhaps at the nighttime because it will disrupt their sleep, or maybe for very extreme noise events, the crossing of a train, or maybe it's sirens because of an emergency. With that, Stefano, I'll pass it on to you for theme C.
So we have looked at the theme that focused on understanding people. And then we had the other theme looking at the outdoor. Now we go indoor. We go within building. And this theme is composed by experts in civil, mechanical, material, energy, architecture, engineering. And we also have a physiology to best understand how the thermal environment affects people. Why do we care about the indoor environment? Because we spend most of our life inside buildings, and buildings affect our health, affect our mood, affect our ability to learn, affect our ability to get our job done. Moreover, a lot of resources are used for building to keep them comfortable, light at night and cooling when the heat is outside is very strong. We want to provide technological innovation that can support smart and resilient building design and operation in order to improve the quality of life of people, and at the same time doing that with the minimum amount of resources. During our previous program, we focused on building, and we introduced the concept of increasing temperature set point and providing fan to compensate for that. We can save energy and make people happier. In this case, we want to propose a significant improvement compared to that. We want to try to switch off air conditioning in Singapore, of course, when it's proper. How are we going to keep people comfortable? It's a combination of three factors. First is a type of radiant system where there is not the risk of condensation because the temperature is set at a high temperature. Open windows when that is allowed, when outside there is no noise, when there is no pollution, that allow the abundant amount of air that dilute the risk of spreading of disease indoor, and then a wearable cooling device that can keep you comfortable. And when the conditions outside are not favorable, then we can close the building and still we can save energy by having the air conditioner at a higher temperature set point. Let's talk a little bit about this wearable device. This is a thermoelectric cooling system. There are a couple of examples in the market that you can see in the higher part of the image. One is from Sonic, the other one has been developed here in the United States. And we tested this type of system in our lab at Berkeley, and we prove that this device can allow the temperature set point to be increased up to 3 degrees. We think that this system can be improved. And we create a team of people that have expertise in material science, in mechanical engineering, with people that have expertise in physiology. And we want to develop adaptable, bendable material that can provide the right cooling condition in the right body location. This type of wearable go well with other projects that are relevant for other teams, that is using wearable to collect information. For example, this app that has been developed jointly together with NUS allowed collecting momentary assessment of what people think or how they feel in a specific condition. When the pandemic hit Singapore, we helped the Singaporean agency to develop guidelines on how to reduce the risk of spread of the virus indoor. Since then, we learned a lot about the virus. We know that now the aerosol inhalation is one of the main mechanisms for which the virus is spread. And so we may need to change in some condition a little, in some other condition very massively how we design and operate building. For example, we know that in office environment, probably small change will allow us to be in a safe condition. But there are other situations, like for example, a gym, where we may need completely change and revolutionize the way that we condition those space. We need to know how much air do we need to provide, which are the trade-off between energy and ventilation, which type of air conditioning mechanical ventilation system are the best to reduce the risk of spread of disease. Will be people comfortable in this condition? And what should we measure in order to control in an energy efficient and clever way these systems? We want to answer to those questions.
I pick up now with theme D, which is the theme that brings us back to the city scale and to the policy scale. And here we bring a team that has expertise in economics, in psychology, in transportation, in city planning and engineering, all coming together with an interest on policies on the built environment. The motivation for this theme is that a competitive, livable, and resilient Singapore will continue to be a global leader and adopt policies that promote well-being, health, and sustainability. So it's really the lead that Singapore has been exerting that motivates this type of comparative research that I'm going to describe in a minute. The main mission statement for this theme is that we will contribute to the main goals of SinBerWELL by focusing on policies and practices that influence well-being and sustainability through innovations in land use, in energy, in buildings, in mobility, and in the way data is collected and harnessed to inform these choices. Next slide. The mission statement that I just described relies on a view that well-being and sustainability of a city is really dependent on upstream policies and plans of the public sector and of private players, and of their capacity to implement these plans and these policies and the rules and their regulations that follow. Urban planners, for example, on the left-hand side here, and policymakers design plans and implement policies that promote various goals. Implementation of such policy and planning results in built environments, in neighborhoods, in precincts, and different choices for people. All of these intermediate outcomes that ultimately play out into health, well-being, and sustainability. It's understanding those upstream elements that really bring focus to this theme. Next slide, please. The projects in the theme that distinguish them from other themes in this proposal really are broad-based, looking at multiple benefits and costs. We intend for the findings and results to be relevant for urban-level policymaking, not only in Singapore, but also in peer cities. Our activities focus on conducting evidence-based research that will inform the testing, design, and implementation of plans and policies at an urban scale, focusing on technological innovation. This includes inventorying of existing plans and policies. That's that upper right-hand side circle that you see here. Case study comparisons with other global cities, or scaling of policy ideas from the themes A, B, and C that we just described to the city level, and evaluating the effects of these policies on the well-being of various subpopulation. And I end the presentation of this theme with a metaphor of an iceberg, which is the next slide. To suggest the policy landscape, 10% of an iceberg is visible above water. These are the targets that are announced by politicians and policymakers. For example, zero carbon emissions, or 100% electric vehicles, or a certain travel time limit. These are the visible ones. Several cities have indeed set some targets and travel times. Melbourne says 20-minute neighborhoods. Paris says 15-minute neighborhoods. Singapore has identified a 45-minute city target to be achieved by 2040. 90% of the iceberg, however, the part underwater, is the policy work that is needed to announce those targets and to try to achieve them, measure progress, review the land use, the transport plans, the policies, review the appraisal frameworks, consider the trade-offs involved. Those complex systems, that modeling of the work that needs to support the policy leads. For a project example, we could study the 45-minute city target of transport investment to think about the appraisal frameworks and how will we integrate these results of the research across the various themes for improving the environment, health, and well-being, with the objective of also improving how projects get appraised in order to achieve these broader goals. Thank you, Stefano.
The last team is the data team. It's the team that focuses on the digital transformation of the built environment and the urban environment. It's composed by experts in electrical engineering, in computer science, in building technology and city planning, all of them with a focus on data science. In the past few decades have brought in abundant computing power, storage, connectivity, and decreasing cost, thanks to the progression both in software and in hardware. In addition, advancing machine learning had transformed the growing data created in the built environment into actionable insight. We realized that policy and decision must be data-driven. And so we want to collect, compile, and analyze relevant data set. We will provide the analytical and simulation platform for doing that. We realize that there are major silos for different types of data set. Some of them at a human scale, other them at the building scale, other are the urban scale. For example, we are interested on people exposure. We want to know where people are and which are the people preference. And this information would be very valuable to better control buildings. And information on how buildings operate together is valuable at the community scale, like for example, in the district cooling example that was mentioned before, or more at the urban scale, if we think about the electrical grid. We want to understand this pattern after putting them together, and we want to integrate with both sensing and people feedback. Here's an example developed from a colleague at NUS. Here we have the ability to understand where people are in time and assign them effectively to specific part of the building. If the building have that information, then the building can react and provide to those people the necessary service, like the right thermal condition, the right air quality, the right temperature. We also want to continue our work on developing digital twin. Why do we want to do that? Because digital twin that are physical, that are digital representation of physical object, allowed us to assess future scenarios. They allowed us to better understand how the physical object is working, when it's getting ready to fail, or when there is the need for better maintenance, but also allowed us to better understand how to control it in an optimal way. We have been working, for example, on developing a digital twin of the lab that we develop in the Create Tower. And here we have a physical model that is connected to its digital part. The two talk to each other and the information flow freely from one to another. We do this type of things because we understand that in order to be effective, we need to measure what is difficult to simulate and simulate what is easy to simulate. There are two different approaches to this type of problem. On one case, we call them white box model, the one that try to represent the physical reality with the most accurate equation, taking them from physics, from chemistry, and so on. The advantage of this system is that they tend to be robust, but they're very difficult to develop. They require a lot of information. On the opposite side, we have black box, the one that, for example, here are represented by a neural net. In this case, these ones tend to be faster to develop, but their outcome has uncertainty, not always is reliable and robust. We want to merge these two techniques in order to take the best of the two worlds in order to develop better prediction and better digital twin. Our entire program and the philosophy of our group is based on the idea that we want to test our condition. We want to test our hypothesis. We want to test our intervention. And we have done it in the past by developing this lab that we have been using extensively in the last 5 years, and also in developing this practical implementation of some of the idea at the BCA Zero Energy building. This is somehow in our DNA. And we want to still use some of these resources because some of the questions we pose can be answered here, but we also understand that we have new questions that will need a different test bed. And we hope to work together with partners in Singapore. We started already some of the discussion about this in order to develop and do intervention at the precinct level or at the community level. We see an opportunity like the construction of the super low energy building at BCA or the development of the Punggol Digital District or the Tenham Forest as opportunity to test our idea. In order to do so, we need collaboration. We already obtained several collaborations with the industries that are listed here. Some of them are endorsed our proposal, and we started to have deep conversation with several agencies in Singapore. We understand how important is this interaction with both the public agency and the industry partners. When we started many months ago the development of this proposal, we studied what was ongoing in Singapore. We talked with a relevant research group in order to understand what they were doing and how we could propose a unique proposal that was complementary to the existing effort in Singapore. We aim to assemble an outstanding team of research, both from Berkeley and Singapore, with expertise that go from engineering to public health, from data science to psychology. This team is unique because it merges people with diverse skills with one objective: increase the livability and sustainability of Singapore by managing the digital transformation that is going to shape our city in the years to come. Let's do this together.
Thank you very much for your talk, Prof Schiavon and Prof Rodriguez. We have a couple of questions. Maybe first off, we'll go with someone who's raised his hand. By Song, would you like to ask your question now? Alternatively, we'll go to the Q&A question first from the box, if I can read it out. At what people density, based on the number of persons per square meter, does the trade-off move from personal cooling or wearables to central room air conditioning? Is that a number we have a sense of already, or is it still a research question?
So we think that in many conditions, air conditioning will not go away. It will just be reduced less. And personal cooling, when we think about that wearable solution, it's one person. There is no more than one. But there are also very localized cooling conditions, like, for example, the use of ceiling fan that we already explored. And then there are situations when we want to apply this solution when people are in this transitional space. Many buildings now in Singapore start to have space that are not completely outdoor and not completely indoor in order to save energy. In those spaces, this type of wearable cooling solution or the increase of air movement may give the high potential of energy saving and better comfort. So we don't think specifically on square meter per person or people per square meter, but we see about application of these ideas.
Okay, thank you. I think Dr. Lim, you have a question too?
Thank you, Stefano. My question is actually follows on from the previous question and also from what Li Min spoke about earlier. Now you have, the team has great experience with doing the sorts of measurements, teasing out the effects of your work at the building scale. Now, and ambition here now to go beyond the building scale. I was wondering whether you have some hypothesis on where the system boundaries might be that you want to go. Are you sort of proposing to go from the building scale to the whole island scale? Or is there some intermediate district type level that you think would yield measurable data that you can actually draw conclusions from?
So our main scale is the human scale. In this cohort study that we are proposing with the School of Public Health is focusing on following people in the different environment that they go. We do not expect people to move up and down the entire island, even if someone would do it. We think that people tend to follow common pattern of home, work, school, maybe shopping center, hawker center, and then going home, back home. So for our observation of where the exposure happen, we will basically attach to these people. Where do we think we can do the better intervention? We think at the building level. We are not yet proposing intervention at the urban level, even if opportunity emerge, we will try to do that. Daniel, do you want to add something on this?
Stefano, you're absolutely right. That would be my answer. I think that we would follow people and that the interventions could be ecological at different scales. Certainly our experience at the building level is much stronger and well developed. And part of our thinking is that through partnerships, we might look at the precinct, for example, and thinking about a broader intervention level that affects more people, but of course that has more noise. So it's a more complicated. But certainly we will be following the individuals.
Thank you. I think Prof. Thomas Becker, you have a question too?
Yes, thank you very much for this really nice presentation. I have a question. When I heard the statement that you will understand the people there and you want to really optimize the environment, the buildings and all what is concerned with it. For me, it came into my mind whether it's really dependent from the cultures of the persons who are living there or working there. Will you consider the different cultural aspects of the people who are involved, and how you will do this?
We will not try to optimize the work performance of people, how people studies. We realize, as Dr. He mentioned before, by citing Betancourt and indirectly by citing an idea that was developed here at Berkeley, that these one are wicked problems. They're very complex. We are trying to optimize some of the aspect of the exposure. For example, if we learn that most of the exposure happen at home, how can we reduce the penetration of particles that go from the outside to the inside? What can we do if, for example, there is a noisy street in front of a house, in front of a HDB? Then people will close the windows in order to reduce the noise, but that creates problem because then the pollution level inside the house will increase because there will be not enough ventilation and the relative dilution. So how can we integrate a system that bring outside air without bringing the pollutants and without bringing the noise in order to make people sleeping better or reducing the risk of spread of disease among people?
Okay, I think, we do have, it looks like we have another question. I don't, Hong Yuan, would you like to talk this time?
Oh, hi, yeah, good afternoon. So this is, I'm a faculty in EE NTU. Yeah, thanks for the presentation. And Prof Stefano, right? So I want to ask you, when you talking about the gray box modeling approach, well, indeed, for your information, I'm also doing something similar. I use a digital twin. Then I think gray box should be like the trend that how people do when they have the physical model and go together with a machine learning or neural network. Then what you expect that, I mean, if you do the gray modeling, you have different level of the simplified physical model together with the data and together with neural network, for example. So what expects that should be like breakthrough or something you do should be different from what, I don't know, my model, for example.
In this case, the main focus is on the application of this idea to specific solutions. For example, what if instead of having a deterministic model to predict thermal comfort, as is done right now, even from colleagues here in the Singaporean context, to say, okay, how do we assess comfort outdoor? Then there is a simplified physical model. We know that some of these coefficients could be determined based on more granular data. And we want to try to merge these two in order to refine the predictability of some of these aspects. Or some of the subsystem we realize that cannot be modeled properly. For example, if we look at behind Dr. Go image, we have the Create Tower. That Create Tower have a facade that if I try to model the movement of light through that facade, it's kind of too hard. And so we use machine learning approach in order to describe that complexity.
Oh, I understand. Yeah, thank you very much. So Bidney, what you're saying is that you different layers, right? And whatever the difficult to quantify, you put it through machine learning. yeah. Thank you.
Or what is easy to measure, and therefore using the stream of data in order to infer that aspect.
Okay, thank you. Appreciate it.
Yeah.
Prof Daniel Rodriguez, you wanted to say something? Okay, we do have a couple more questions, but we're out of time. I will just mention one of the comments from Terence Tan from, no, sorry, that is an anonymous attendee. Someone mentioned that the founding Prime Minister, Mr. Lee Kuan Yew, mentioned that the greatest innovation yet to be made is air-conditioned underwear. So we look forward to that if possible. But
let's say that we fully agree. The key is that we want to provide comfort in an energy-efficient way, and maybe we have new innovation that can provide the productivity and the sustainability together.
Looking forward to that someday. Moving on, thank you very much. Sorry?
Michelle, there are some other Q&A. I suggest that those who like to respond to that, just respond directly on the Q&A chat.
Yeah, so you can just type directly into the Q&A chat box. That'd be great. Thank you very much.